Greetings and welcome to another ramble with me. We are looking at IEB's paper 1 from May 2025. Question 6a. For a certain sample set, the following results were measured regarding events S and T. The probability of S is 0,7. The probability of T occurring is 0,2. Determine the probability of S or T happening if S and T are mutually exclusive events. So if we were to look at it as a Venn diagram, for example, there would be S, there would be T, the probability of S happening being 0,7, the probability of T happening being 0,2. And so the probability of S or T happening would just be the sum of each event happening. Right, so the key there is recognizing what this means, mutually exclusive. There is no intersection between the two events. There's no chance of S and T happening at once. So that's the one question. Then we're asked, what is the probability of S or T happening if S and T are independent events, right? So what that means is there could be an intersection between the two. However, the probability of S happening is not influenced by T happening, right? So for example, if you think about, if the event S is the chances of it raining today, and the event T is the chances of me wearing my boots, my rain boots, those are dependent events, typically, right? Because me wearing my boots is influenced by what the weather is like, right? So the probability of me wearing boots on a sunny day is going to be different to the probability of me wearing boots on a rainy day. Whereas independent events would be, something like rolling 2 die. What are the chances of getting a 6 and a 6? Even though intuitively it feels like if you get a 6 on the first roll, the second time there's going to be a smaller chance of getting a 6, that actually isn't the case. The two events are completely independent, and the chances of getting a 6 each time is going to be 1 out of 6. So that would be an example of two independent events. Anyway, so what we know about independent events is that the probability of S and T happening is the same as the probability of S happening times the probability of T happening. So these are things that we need to remember when we see these keywords: independent events, mutually exclusive events. Right, so we also know, using the name of a rule that I've forgotten, that the probability of S or T happening is the probability of P of S happening plus the probability of T happening minus the probability of S and T happening. Reason being, if we look at it as a Venn diagram, the probability of S or T happening is this guy over here, right? So if we were to just simply add the probability of S and the probability of T, we would be counting the probability of S and T happening twice. So that's why we need to remove one of those. Anyway, okay. So in this case, this will be the probability of S happening plus the probability of T happening, and then we know how to work out the probability of S and T happening, which is given by that, because they are independent events. So that would be 0,7 plus 0,2 minus 0,7 times 0,2. I think that comes to 0,9 minus 0,14, which would be 0,76. Right, and that's that on that. Let's have a look at what the memo thinks. So I need to go down quite a bit. Okay, so 6a, for the mutually exclusive events we get 0,9, and for the independent events we do indeed get 0,76. Perfect.